Welcome back to Homework Help with Miss Gore. Today we're going to be talking about our Unit 10 Day 6 homework, solving systems of equations graphically and algebraically. So the first thing we're going to talk about is we're going to skip down to problem 3. All right, so in problem 3, the first thing I need to do is I need to isolate my y value so that I can graph my equation. So I'm going to subtract my 2x squared from both sides, giving me 2y equals negative 2x squared plus 18. I'm going to divide that by 2, giving me the quadratic equation of negative x squared plus 9. So I'm going to go to my graphing calculator, and I'm going to go to my graphing calculator, and I'm going to plot that equation, and I'm going to try to find a table that gives me an appropriate range of values. So in my table, I want to go from negative 4, that's a negative 4 squared. So it's going to go from negative 4, negative 7, 3, 0, 2, 5, negative 1, 8, 0, 9, 1, 8, 2, 5, 3, 0, and 4, negative 7. And I'm including so many values because I'm looking for my graph to have a nice shape to it, and having more values is going to be helpful to me. So I'm going to count out a scale. And now I'm going to plot my points. So negative 4, negative 7, negative 3, 0, there's a root right there. So negative 2, 5, negative 1, 8, 0, 9, 1, 8. So I identified my vertex up there on top, 3, 0, and 4, negative 7. All right, so draw the parabola. Oh, I did not do a very good job drawing that, so hopefully you're going to do better when you don't have a stylus in your hand. And I'm going to label that equation for myself. I'm going to label that with the original, remember? So 2x squared plus 2y equals 18. Now the second line that I need to graph, second line here, is x equals 3. Now remember, in x equals 3, my x equals 3 is a vertical line, and it is going through the x-axis. Here is my x equals 3 value. Now notice that I did a very poor job graphing that parabola back there. So I need to kind of clean this up over here. Okay, so I'm going to go back, I'm going to clean that up. And I'm going to clean that up because I was not terribly precise. What I'm seeing now is that this actually had one intersection point. That intersection point's right there. And so my solution is the point 3, 0. And this is a question that cannot be checked on the graphing calculator. Make sure that that's labeled. Because again, I cannot graph x equals 3 in there. All right, let's move on to an algebraic. Okay, so let's talk about question 5. So in question 5, notice that both of my equations are already isolated with my y value. So that's really helpful to me. And now what I want to do is I want to set my two equations equal. So I have my x squared minus my 4x equals 3 and an x minus 7. Now, since this is a quadratic, I am going to move everything over to one side so that I now have x squared minus 5x plus 4 equals 0. And now this is in standard form. Okay. So since it's in standard form, I want to try to think about, okay, do I have to factor this? Can I use quadratic formula? Can I complete the square? All sorts of different ways that I can do this. But indeed, this is factorable. So it's going to factor into x minus 4 times an x minus 1 equals 0. Now that I have it factored, I'm going to set both of these equal to 0. And I get for my x values, x equals 4 and x equals 1. Now that I have those x values, what I want to make sure that I do is I take them and I plug them back in. Now I'm going to pick the easier equation. So y equals 4 minus 7, so y equals negative 3. So that means that I have one intersection point of 4, negative 3. Then I'm going to take my 1, and y equals 1 minus 7, which is going to give me a negative 6. So giving me another solution of 1, negative 6. Now I can take both these points and I can plug them back into both equations, giving me 4 checks. or you can use a graphing calculator, graph them, and find where they cross. Hopefully that helps. Have a great day.